Hi, welcome to Cloud on Air, live webinars from Google Cloud. We are hosting webinars every Tuesday. My name is Feng Lu, and I'm a software engineer at Google. Today, I'll be talking about the Cloud Composer. You can ask questions anytime on the platform, and we have Googlers on standby to answer them. Now, let's get started. So today, I plan to cover the following topics. I'll start by giving an overview of Composer. Next, we'll talk about how to use Composer, followed by a demo. And I'll wrap up my talk with pointers on how to get you started. So before we start, what's Cloud Composer? What kind of problems are we trying to solve here? In many cases, we find the need to run something, run a task, or run certain operations at a predefined interval, or in response to an external input. We not only find that in our workplace, but sometimes it happens in your life as well. It's just the case that you don't realize that. For example, you may have an alarm that wakes you up, every day at 8 a.m., or you may want to send an email every Thursday night. So for a task as simple as that, cron, which is a Nix, is a utility in Nix operating system, might be sufficient for your need. Sometimes when your task gets a little bit complicated, for example, you may have a few tasks, and there are some dependencies among those tasks. In this slide, I have an example in the middle. Imagine that you have a Google App Engine application, which is constantly dumping logs into the Google Cloud storage bucket. And every once in a while, you want to run a data flow job that process and clean up those logs and save them to BigQuery so that you can run useful metrics, useful analytics from the user data. Even a task or a workflow as simple as what I just described, if you think about how you want to implement that, it's actually a lot of work. You need to make sure you understand the API to talk to the various cloud services. You need to make sure you have the right authorization and account in place. And not even to mention that you have to worry about failures. There could be service failures, network failures. So at the end of the day, you realize that you spend a lot of time not actually focusing on your workflow, but rather on all the infrastructures that runs your workflow. I probably will not even attempt to try to use cron to run a periodic machine learning pipeline. That's just too complicated. So we believe that it should be easy to create, schedule, and monitor workflows that work inside and outside of Google Cloud Platform. With that mission in mind, we introduce Cloud Composer service. In a nutshell, Cloud Composer is really a managed Apache Airflow service that makes workflow creation management powerful, consistent, and easy for you. We started the Cloud Composer project with a number of product goals in our mind. We wanted to have a comprehensive integration with a lot of cloud services. So like I mentioned earlier, as a workflow author or workflow user, you don't have to worry about talking to the various cloud services. So we do want to provide high-level abstractions so that it makes it easy for you to start using other cloud services. We also don't want to limit your workflow to GCP task only. We want it to be the case that it's as easy as for you to start jobs elsewhere. For example, in another cloud provider, or even on-prem as starting a job in Google Cloud Platform. We want to make the workflow specification or the definition of the workflow easy for you as well. So hence, we choose the popular and easy-to-use language Python for you to write your workflow definition. And finally, we want to have open source in the core of Cloud Composer, so that your workflow is agnostic to where it gets executed. You can transparently move your workflow from GCP to on-prem to another cloud provider. So next, I'm going to talk about some of the key features as well as some of the design decisions we have made to fulfill the product goals I just articulated. we really try to, so in Composer, we provide a list of key features, and those key features are centered around three main schemes: simplicity, security, and production monitoring. I'll explain each one in turn. So for simplicity, we have convenient tools like Cloud SDK or Cloud Console for you to interact and manage Composer services. We also make it easy for you to manage your workflow tags. We make it easy for you to manage plugins. And then moving on to the security bit, we use Cloud IAM to manage all the credentials, permissions, and access policies. Composer also comes together with built-in support for Cloud Identity or web proxy, so that your workflow monitoring web server is secured and protected. And finally, we realized we also integrate with Stackdriver to provide you with logging and monitoring metrics, so that you can build a dashboard to visualize the internal state of your workflows, and also alert you when your workflow is not running well. I'm going to discuss like a key concept in Cloud Composer that's called environment. So what is a Composer environment? It's nothing but more than just a managed deployment of Apache Airflow. Inside a single GCP project, you could have multiple environments, and those environments are perfectly isolated from each other. In each environment, we provide you with a cloud storage where you can manage your DAG sources or your workflow sources. And you also have the stack. We also provide you an individual workflow web servers for you to access your workflow status pertaining to that specific environment. Finally, we have Stackdriver that provides convenient tools for you to navigate through multiple environments. And last thing I want to mention that each environment is protected by Cloud IAM, so you can configure permissions individually for each environment. Now we're going to talk about some of the design decisions. Earlier I mentioned that Composer has open source in its core, and there are a lot of open source orchestration solutions. Why we settle on Apache Airflow? For those of you who are not very familiar with Apache Airflow, here's a bit quick history on it. It was originally from Airbnb, and that project gets donated to Apache Software Foundation. It's in incubation stage now, but soon to graduate. We choose Apache Airflow for a number of benefits. Number one, it's open source. It's based on Python, easy to use. It has a lot of well-established interface today. You have web server. It has a very nice web server, convenient command line tools. It also has an experimental API server for you to interact with the service programmatically. One thing I want to highlight for Apache Airflow is that it has a very powerful and flexible scheduling and dependency mechanisms. So pretty much you can encode a lot of different dependency relationships among your tasks in a workflow. It has a lot of community contributed connectors. For example, you have connectors to AWS, Google Cloud Platform, interface to a lot of databases as well. And last thing is the Apache Airflow community is very active. There are lots of commits, many developers. Overall, it's a fairly active community. On the downside, I think it's probably when the project got started, it wasn't really focused a lot on, for example, like a production setup, permission management, logging, debugging, and all that stuff. For example, we don't in Apache Airflow, we don't really mandate, say, how you want to run your web server. How would you scale your machines when the workload gets more? So those happen to be the things that Google Cloud Platform is good at. So in Cloud Composer, we provide infrastructure scalability. We have security built in with Cloud IAP as well as Cloud IAM. We make it really easy for you to deploy DAGs, and we have static driver logging and monitoring for you to make sure your Airflow environment is running well. I also want to mention another point is that Google doesn't intend to just fork a copy of Apache Airflow and just make a service ourselves. We want to work together with the community and together enhance and improve Apache Airflow. So in the past, we have worked together with the community to contribute the Kubernetes executor back to the Airflow community. As I mentioned, Composer/Airflow comes together with a number of built-in services. I'm not going to read out all the services. Some of the notable ones are BigQuery, GCS, PubSub, Dataflow. So you, as a Composer user, you don't have to worry about how would I interact with those services. Instead, Composer or Airflow provides nice operators for you to start interacting with those services without worrying about authentication and API details. I'm also going to give you a little bit of details on architectures, how we build Composer. So if you look at the overview of the architecture, it has two projects. One is the customer project, and the other one is the tenant project. So custom project is really the things you see on a daily basis when you log into a Cloud Console or you use Cloud SDK. So those are the projects owned by you, and you have full admin control over those projects. On the other side, there's tenant project. Tenant projects is also a Google Cloud Platform project, but those projects are owned by the service. In this case, it's the Cloud Composer service. We decided to host some services in tenant project for enhanced security and better isolation. We'll come to that point in a minute. In this setup, we try to set up in a way that sort of like reflects the popular Airflow plus serial executor config. Given the microservice nature or the framework of Airflow, our implementation also sort of reflects that structure. For example, there will be an Airflow scheduler service, there's an Airflow worker, there's also an Airflow web server. So Airflow scheduler and Airflow worker, we host both inside a Kubernetes executor, inside a Kubernetes engines in the customer project. And then for Airflow web server, as I mentioned, we host that web server in tenant project so we can have integrated and built-in support for cloud IAP protection. Instead of configuring IAP yourself, Cloud Composer does that for you, and you manage that access to your web server using Composer permissions. In addition, you probably have also noticed that we have put the Airflow database inside the tenant project as well. The reason behind is that we believe since Airflow stores connection, which is the access credentials in Airflow database, so we want to make sure that that database is only accessible to a very narrow set of users or service accounts. In our default setup, the Airflow database is only accessible to the service account that you used to run the Kubernetes engine. By the way, during Composer creation, you have the choice to specify which service account you want to use to run your Kubernetes engine. So let's move back to the customer project. We have Redis, which is the serial backend for messaging distribution, and we have the SQL proxy for accessing the database. Moving down the graph a little bit, we see the DAGs, plugins, and logs. Those folders are all created inside a per project, per environment Google Cloud Storage bucket. Again, Composer manages the distribution of the DAGs to your various Airflow services, so you don't have to worry about whether how do you make sure your Airflow service gets synced to the latest DAGs. Likewise for plugins. In Airflow, the plugins are for you to write customized operators. here, Composer would also take care of plugin integration into your Airflow services. And finally, at the bottom of the left side bottom, you see the logs, the stack driver logging. In addition to Airflow logs, the scheduler and worker logs are also saved in Stackdriver. We do that so that it provides a centralized place for you to navigate through all the logs, but in addition, also try to make streaming logs really fast and really on time for you. So here's a quick recap. We have just talked about what a Composer is, the problems Composer tries to solve, some of our initial product goals, some of the Composer notable features, and our design decisions. Next, we're going to talk about how can we use Composer to actually author and schedule a workflow. So to create and access Composer environments, there are 3 ways. You could either use Cloud SDK, which is our command line tool, or you can use the Cloud Console, which is the UI tool. And finally, you can also interact with the service programmatically using our API. There's no additional setup step you need to do when start to work on workflows. Once the Composer environment is created, the next thing you need to do is to focus on your workflow development. In the context of Apache Airflow, it's also called DAG, which stands for Direct Acyclic Graph. What that means is in your workflow, you shouldn't really have cycles. So here's a quick example about how a typical workflow or DAG would look like. Imagine that you have some files that is hosted on-prem in HDFS, and then periodically you want to copy that file. So for example, if you detect that new files, then you want to copy that files to GCS bucket. And once the data is available in GCS, you may want to launch a BigQuery job and then try to process the data and then get some useful insights from the data. And once that insights is available, you may want to send out that data to a Slack channel. So that could be some of the typical workflow you will run inside Composer. There are about 5 steps really for you to write an Airflow DAG or workflow. We summarize that into 5 steps. Import, write arguments, do your DAG setup, lay down the various tasks, and then encode task dependencies. So this is the standard part. Before you write your DAG or workflow, you import all the necessary libraries. In this case, you want to make sure you import the DAGs, the operators from Airflow. And if you have specific or customized trigger rules, you also want to import that from Airflow as well. And once you have the import in place, you could start to construct your arguments. So Airflow DAG has a default DAG argument section, which for you to specify high-level arguments that apply to all tasks in the DAG. So for example, you can specify like when you want your DAG to get started, whether you want to receive email when there's a DAG failure, and if a task fails, how many times you want to retry that task, what's the delay between consecutive retries. So this ties back to my our earlier discussion on writing workflows yourself. I mean, in this cron plus scripting example, you have to worry all those retries yourself, and you have to actually build your own email operator inside so that make sure you get notification when a DAG or a workflow fails. Here in Composer or in Airflow, you get all that being provided for you already. The only thing you need to do is write your configuration and leave all the details to Composer or Airflow. So after that, if you have additional global variables that you plan to use in your DAG, again, you can list them here. So for example, here we have the GitHub table, we have the output file, and the BQ dataset names. After that, you start to set up your DAG by giving the DAG a name, define an interval that how often the DAG should be triggered and executed. And then, of course, you pass the default arguments to your DAG. That's one thing I want to highlight here is that make sure that your schedule interval is set here. You can't set a schedule interval in the default args. It won't work there. So that's the one thing I want to point out when you write your DAGs. The next step is basically lay down all the tasks you need in this workflow. So in this specific example, we have 2 tasks. One is about running a BigQuery task. The other one is publishing the BigQuery output to GCS. As you can imagine, you can have as many tasks as you want. Airflow also allows you to programmatically generate a task. For example, use a for loop to generate an array of tasks. So all these are entirely possible in Airflow. And finally, you specify the dependency or orderings among your tasks. In this case, what this line says, I want to run my BigQuery first before I expose the result to GCS, which make a lot of sense in this case. Once you have everything together, then you're good to go. So now we're going to give a live demo on using Composer so that we tie all the concepts we have discussed. Now, back to the demo. For the sake of the presentation, try to save some time, I have pre-created a Composer environment. So if you click on one of the environment, I call it in this case, it's called a Composer demo. It has a number of tabs, and then you got to see all the details that pertain to a specific Composer environment. I'm going to quickly go over some of the properties. Don't worry if you can't read out the text on the screen. For example, you have an environment name, you have a location, whether that environment is running in US Central or Europe West 1. You got a chance to specify a service account. There's also a specific Composer version that you are running in this environment. There's some details related to the worker node, which we use to run Airflow scheduler and Airflow workers, like the machine type, the disk size, and etc. There are 2 things that you will want to pay special attention. One is called DAX folder. So if we click through that DAX folder, leads you to a place where all DAGs should be staged. To deploy a DAG is as simple as drop a file in this DAX folder. And likewise, you realize that there's another one that's called Airflow Web UI. If you click that Web UI, that leads you to the familiar Airflow Web UI interface. You get all the, you would be able to access all workflow-related information as well as some of the configuration under admin panel. In order to access this Airflow web server, you need to make sure that you have the right permission. So I skipped the part since I've already logged in. It probably won't prompt me for login. But if you're going to create one yourself and try it offline, you probably will see a login window prompting you for email and password. So that's the way how Cloud IAP works. It checks that the user has the right permission before it allows you to open the Airflow Web UI. So as I mentioned, deploying a DAG is as simple as dropping a file here. So let me get that started. So I'm going to upload a DAG file. This DAG file, in fact, is called Quick Start. In fact, the Quick Start guide in our cloud documentation website. So I'll just upload this one. It's done. It takes a few minutes for Airflow to pick up the DAG and start execution. While waiting for Airflow to pick up the DAGs, and then I also want to give you some quick overview on some of the other configuration you could be able to do in Cloud Composer. We allow you to update Airflow configuration in real time. So for example, if you want to hide the configuration in the admin panel, you could just make a change to say, hey, web server expose config to false. After that change, your configuration will be hidden from the login users. We also allowed you to install PyPy dependencies. Imagine that your workflow requires, say, Slack client to be installed or SignPy to be installed. You could simply just use the PyPy package management feature in Composer and then specify the packages you want to install. So for example, you could add a package, you could add a Slack client, and then you can also specify option of version string. So that's all you need to do. After that, you click submit. That's all you need to do to get the dependency installed for you. Now let's come back to the Airflow web UI. Let's do a refresh, because Airflow web server doesn't do refresh by itself. There we go. We see the quick start to appear in the web UI. Because, as we mentioned earlier, Airflow is a microservice architecture, so you have a web server component. It also has a scheduler component. Those components are not perfectly synced. So sometimes if you see things like tags being recognized in one place but not the other place, just give it a few more minutes. We'll just do a few more refreshes, and hopefully we'll see that DAGs being shown soon. There we go. So click through the DAGs. It has different views for you to navigate through your DAG structure. There's a graph view, so that you see that we have 3 tasks, like create a data product cluster, run a simple word count example, and then delete the data product cluster. There's different views, like graph view, tree view, and you would also be able to see the details. For example, like how long does it take for a particular task to complete. In many cases, if you want to inspect the code, you could also see the code here. So let's go back to the web UI. Right now, we are in the stage of trying to create a data product cluster. So we can go to view the logs, see what has been done, what has been specified there. This essentially says, hey, right now this task has started. Some of you may wonder, like, given that Airflow already has workflow or task logs, why you still want to provide work logs or logs in Stackdriver? Here's one difference. If you go to Stackdriver logging, go to Composer Demo, and then go to Airflow Workers. You actually see a lot more things here. The reason between said differently, Airflow tries to upload logs periodically. So whenever it comes together with depends on some internal cause, so you don't always see the latest logs. But with Stackdriver logging in Composer, you would be able to see all the logs that happen in real time. Sometimes, if you happen to have a task that takes a while to complete, let's say a few minutes, or in some extreme case, maybe an hour to finish, at least you want to be able to see those logs earlier. So Stackdriver logs would be the place where you could see all the streaming logs. Let's go back. As we can see, the first task, the create data product cluster task is done. Now we move to the word count task. One thing you notice that Airflow also has a UI to highlight the different stage of the task. For example, if you get a dark green when the task is done, relatively light green when the task is still active. I will give you a few more minutes to let the workflow to complete. But as you can see, once the task is done, you would be able to see a lot more details in the log. So those contains all the logs that are emitted by Airflow. I want to say that those logs are very helpful. Sometimes when you have a task failure, you have no idea what's happening. Those logs provides the initial place for you to do investigation. A lot of times, the failures or exceptions will be logged here. You could also there are other views for you to manage your task. They provide task views, which you see tasks from all workflows running in this environment. You would also be able to see the active DAG runs. So you have DAG view, task view. Depends on your need. They're very flexible for you to navigate through your workflows. Sometimes you can also create a manual run in case, for example, if you don't want to wait until if you don't want to wait until the scheduled interval, it is also possible for you to just create a manual run yourself. Just put the DAG ID, give it a run ID, and then click save. That will start a manual run of the same workflow. Now we have seen that all the tasks has been successfully completed, and then you also have some of the stats here as well, like how long does it take for the task to complete. Yeah, so that's the end of the demo. We're going to switch back to the slides. So here's a quick recap on the demo. We just illustrated, we just showed you how to, we skipped the part of creating a composer environment. There's a reason why. I'm going to discuss that. And also give you different ways. In this case, we primarily focus on Cloud Console for you to access the composer environment. But it is also possible to interact with composer environment using Cloud SDK or even the API. Next, we've shown you how to upload a DAG as simple as just drag and drop a file into the GCS bucket. And then we have walked you through the various UI features comes together with Apache Airflow web server. And finally, we also talk about why we want to use StackDriver to examine composer logs, so you don't have to wait until the task is done, so you can see streaming logs coming in as the task executes. I'm going to wrap up the webinar by saying, giving you some pointers to get you started. Given Composer is a managed Apache Airflow service, so all Apache Airflow concepts would apply in Composer. We recommend you to go over the Apache Airflow documentations and also some of the start guide there. They have very good documentation explaining the concepts of DAGs. They also give you a lot of tutorials as well. Specifically on the Cloud Composer documentation website, we'll also give you all the details about how would you interact with the Composer environment, how would you create an environment, how would you manage your environment, and how would you access your environment. In addition, we'll also give you price information, how would you monitor your Composer environment, how to interact with StackDriver overflows, how to interact with StackDriver logging and monitoring. And finally, the team is trying to add more DAG examples in Composer. So we have a few examples in the GitHub, but the team plans to add more there. So that'll be the end of the presentation. Stay tuned for the live Q&A. We'll be back in a few minutes. Welcome back to the Q&A session. So I'm going to read out the questions posted here. So the first question is about how long does it take to create my Composer environment? We have received some customer feedback saying, hey, it seems to take a long time for me to create my Composer environment. Sometimes it can be 15 or even 20 minutes. The reason here is that together with Composer, we also host a Airflow web server inside a Google App Engine. And for those of you who have used Google App Engine in the past, you probably know that it takes about 50 minutes to get your App Engine app created, initialized, and stabilized. So that's the reason why creating a composer environment takes 15 to 20 minutes. Now, the second question is about how do I get email notifications when the workflow fails? If you still recall, when we worked through the DAG structure, in one section, there's a configuration option in default args section where you can say, hey, email on failure or receive email notification. You also need to put by the way, you also need to put an email address there. So given there are some limitation in Google Cloud Platform, mainly from spam and security perspective, that you can use SMTP directly when running your application in GKE. So instead, we use, in this case, we use Syntegrate for all the email notifications. To configure email for using Syntegrate service, really you only need to supply an email and Syntegrate API key as well as a form address. And then those can be configured as part of your composer environment variables. Our documentation website has a lot more details about how do you be able, what kind of environment variables should be put into your composer environment to get an email working for you. The next question is about which Apache Airflow versions does Composer support? That's a very good question. So right now, Composer only supports like Airflow 1.9. It's on our roadmap to support multiple versions of Apache Airflow. So for example, at environment creation time, you could specify, hey, I want to use Airflow 1.8 or 1.1 or Airflow 1.10. So those multi-version support is on our roadmap for sure. But right now, only 1.9 is supported. The next question is, do you have any suggestion on migrating on-prem Airflow setup to Composer? So ideally, given Composer is a managed Apache Airflow solution, your DAG should work transparently across on-prem and GCP and vice versa. Sometimes we do notice that if your DAG has reference to local environment, for example, if you try to refer to local file systems or other sort of non-standard Airflow operators, those might be a friction for you, so you want to make sure those get corrected. And then if you make sure that your workflows doesn't refer to anything in your local environment, then in addition of copying your DAGs from your on-prem to Composer, the other thing you need to concern will be the Airflow database migration. If it's the same Airflow version, the migration can be as easy as export your database data and then import that again in Composer. Or you can, if you don't want to retain all the history, you could also selectively just copy over the configuration, the connections or variable configurations you need. Next question is, can I orchestrate a hybrid environment with Composer? Yes, that's totally possible. So you could have tasks running on Prime as long as you make sure that, for example, there's a network, you have the right network connection set up in place. Composer or Airflow is really agnostic to the type of task that gets executed. The next question is very similar. Can I orchestrate a multi-cloud environment with Composer? Yes. As I mentioned earlier, there are connectors to not only to GCP, but there are also connectors to AWS or Azure or other cloud providers in Apache Airflow. So really, the only thing you need to do here is to make sure you have the credentials configured as connections in Airflow or Composer. And afterwards, when you try to instantiate an operator to another cloud provider, make sure you refer to the right connection name string. So that's all you need to do. The last question is about, I have a lot of tasks in my workflow. How does Composer handle Airflow worker scaling? Very good question. For now, we do the Composer API service does allow you to manually scale the number of workers. So for example, if you realize that, suddenly you have a burst of tasks where you need to start maybe 1,000 tasks, and all your machines are running short of machine resource. What you need to do is just log into the Cloud Console or use Cloud SDK to upsize the number of worker nodes you have. We will automatically manage the scaling for you, as well as making sure that Airflow configurations are updated accordingly to match your cluster size. Notably, there are a few scalability or parallelism configuration options related to number of workers you could have. So those will be taken care of by Composer, so you don't have to worry about that at all. In addition, auto-scaling is also on our feature roadmap, so we may have auto-scaling support sometime. As a result, you don't have to worry about scaling at all. So that will be the end of the Q&A session. Thanks a lot for staying to listen to the webinar, and definitely stay tuned for next Tuesday's webinars.